Hello everyone, my name is S. Vidyarani, working as Assistant Professor of Physics at MBS Government Degree College, Autonomous Mehboob. So in the previous classes we have learnt about all the important theorems as well as vector operators that we use in vector analysis, and I have also shown you how to solve the problems using divergence as well as curl, and how to find whether a vector field is conservative in nature or not. In today's session also, we will see few more problems relating to vector analysis using curl, grad, divergence, and also conservative nature or irrotational or solenoidal. So based on this, we will find out few problems, solutions for few problems. So first let us see the basic question. First we will find out the scalar product of the two vectors. So let us say there is a vector called A which has a values of 1, 2 and 3, and B is also a vector 3, minus 2 and 1. So we have to find out the scalar product. Scalar product means dot product, or else we can say A dot B is equal to A1 B1 plus A2 B2 plus A3 B3 A3 B3. A1 B1 is equal to 1 into 3 plus A2 B2 is equal to 2 into minus 2 plus A3 B3 is equal to 3 into 1. So hence 1 into 3 is 3, 2 into minus 2 is minus 4 plus 3 into 1 is equal to 3. So 3 plus 3 is 6, 6 minus 4, that becomes 2. So that means the scalar product of these two vectors having a values of 1, 2, 3 and 3, minus 2, 1 is 2. So we know that for a scalar product there should be only magnitude but not direction. If you observe over here, the value that we got is in the form of magnitude with no unit vector. That means there is no direction, only magnitude is present. Next, for second question, we will see to find out the vector field. So to find out the vector field of components, so let's suppose there is a function vector field f which is equal to x by y I plus 2x minus 3y into j. So that means f of f1 is equal to x by y, whereas f2 is equal to 2x minus 3y. So we have to find out the divergence of this. So how to find out the divergence? Again, del dot f is equal to dou f1 by dou x, because divergence means I dot I is equal to 1, j dot j is equal to 1. Hence, so there won't be any unit vectors. So dou f1 by dou x plus dou f2 by dou y. Here f1 is x by y, f2 is 2x minus 3y. Hence dou by dou x of x by y plus dou by dou y of 2x minus 3y. So we have to differentiate this value with respect to x. We have to differentiate this value with respect to y. So there is an x term over here and we have to differentiate with respect to x. So this x value becomes 1. So it becomes 1 by y, which I have written over here. Next, we have to differentiate this term with respect to y. But there is no y in the first term, so this value becomes 0. When we differentiate this value with respect to y, so minus 3 into y becomes minus 3. Minus 3 means here I have written as minus 3. So after taking the partial differentiation, the value is 1 by y minus 3. We are finding out divergence of f. If we observe, divergence of f is nothing but scalar product. So scalar product means no direction, only magnitude. If you observe in this whole term, there is a magnitude here, there is a magnitude here. That means all of this is also a magnitude with no unit vectors such as I, j or k. When there are no unit vectors present in the final resultant solution, then we say that it's a scalar but not a vector. Hence divergence of this vector is a scalar. Moving on to the next problem. Let us suppose there is a scalar field f of x comma y comma z, which is equal to xy square minus yz. If you observe here, I am saying that this is a scalar field. That means it should have only magnitude but no direction. Hence, if you observe here, there are no unit vectors such as I, j, k. That means only magnitude is there. That means which is a scalar. I am using this scalar and finding out its gradient. Remember the property, when we find out the gradient of any scalar, its value is a vector. So gradient of any scalar should be a vector. This is a scalar. When we find out the gradient of that scalar, it should be a vector. So to find out the gradient of this function, this scalar, del f is equal to dou by dou x of xy square minus yz into I plus dou by dou y of xy square minus yz into j. This is how we will find out. So when plus dou by dou z of xy square minus yz into k in all the three directions. So when we take the partial differentiation with respect to x for the first term, so we get x value becomes 1. So 1 into y square into, so there is no x term over here. So this becomes 0. Next, if you see here, okay, y square into y square into I plus, if you see the second term, so there we have to differentiate with respect to y. Dou y square by dou y becomes 2xy, which I have got over here, minus, if you differentiate with respect to y, this becomes y value becomes 1, so this becomes minus z, so 2xy minus zj into j cap, minus, if you see here, there is no z term over here, so this term becomes 0, and this value, z value becomes 1, so minus y into k. This is how we will find out the grad f. If you observe over here, whatever the solution that we got over here is having unit vectors such as I, j and k. That means this solution is in the form of a vector. Hence, gradient of any scalar is a vector. So now we will see the vector product of two vectors. That means vector product is nothing but cross product, or we can also say curl. So A is equal to 1, 2, 3, let us say, and B is 3, minus 2, 1. So A cross B we have to find out. So A cross B is equal to ijk, determinant 1, 2, 3 values of A, 3 minus 2 and 1 of vector B. So again taking the determinant, so 2 into I plus 3 into 2 of I minus j into 1 into 1 minus 3 into 3 plus, into j cap plus k into 1 into minus 2 minus 3 into 2 into k cap. So after simplification, 2 into 1 is 2, minus 3 into minus 2 is minus of minus is a plus, 3 into 2 is 6, so 2 plus 6 into I, minus 1 into 1 is 1, minus 3 into 3 is minus 9, so 1 minus 9 into j cap, plus 1 into minus 2 is minus 2, minus 2 into 3 is minus 6, minus 2 minus 6 into k cap. Further simplifying, 6 plus 2 is 8i, minus of 1 minus 9 is minus 8, so minus 8 j cap. Next, minus 2 minus 6 is minus 8, minus of plus is minus, hence minus 8k. Again further simplifying, 8i minus of minus is plus, hence plus 8j minus 8k. This is our final value. If you observe, so this is a vector, this is a vector, we are finding out the vector product, that means using cross product. So the vector product of any two vectors should be a vector. Hence here, if you observe here, we got a vector. How can we say that this is a vector? Because whatever the solution that we are getting over here, it is in the form of unit vectors I, j and k, which represents a vector. Now let us say there is a vector field called f of xyz, which is equal to xi plus yj plus zk. Now from this we can say that f1 is x, f2 is y, f3 is z. Now we have to find out the curl, that is del cross f. When we find out the curl, dou f3 by dou y minus dou f2 by dou z into I cap. So next minus of dou f3 by dou x minus dou f1 by dou z into j cap plus dou f2 by dou x minus dou f1 by dou y into k cap. Substituting the values of f1, f2 and f3 wherever required. So f3 value is z. So in place of f3 I have substituted z. So dou z by dou y minus, here there is f2. f2 value is y. So I have substituted y. So dou y by dou z into I cap. In the same way, similarly we have to substitute the values of f1, f2 and f3. So after substituting, the equation will be in this way. So if you observe, we have to partially differentiate with respect to y, but there is no y value over here. So hence this value becomes 0. If you see the second term of ith value, if you see here, we have to partially differentiate with respect to z, but there is no z value, so this value also becomes 0. So 0 minus 0 is a 0. So 0 into I is 0. So 0. Next, for the second term, again we have to partially differentiate with respect to x, but there is no x term here. So this value is 0. Same way here also we have to partially differentiate with respect to z, but there is no z term over here, so this value also becomes 0. 0 minus 0 again is 0. 0 into j is also 0. Again third term, we have to partially differentiate with respect to x, but there is no x term here, so this is a 0. Minus, we have to partially differentiate this value with respect to y, but there is no y value over here, so this also will become 0. Again 0 minus 0 is a 0. 0 into k is also 0. So 0 minus 0 plus 0 is a 0. So here if you see that curl f value is 0. When curl f value is 0, that means that value is a irrotational vector. So a vector field with vanishing curl, because curl f value is 0, that means it is vanishing. Curl of f is vanishing. Hence we can say that this vector field is a irrotational vector. That means f is called as irrotational vector because its curl value is 0. Now moving on to the other example. The curl of f of xyz, here he has given a vector. We have to find out the curl of that vector. So when we find out the curl of that vector using the same process, again if you see here, we have to differentiate with respect to y. There is no y term, hence 0. Here we have to differentiate with respect to z. There is a z term. So this value becomes minus 2y, which I have written here. Minus of, here dou x by dou x becomes 1. So minus of minus becomes plus. So I have taken plus. Here there is no z term with respect to partial differentiation. So this value becomes 0. Here we have to differentiate partially with respect to x, but there is no x over here. So this value also becomes 0. Here also then we have to partially differentiate with respect to y, but there is no y over here. So this value also becomes 0. So that means only two terms we will get here. So minus 2y, minus of minus becomes plus. So plus minus 1 into, plus 1 into j becomes j. So if you observe here, del cross f value, that means curl of any vector should be a vector. So here we got a value, or cross product of two vectors should be a vector. Here we got a vector. How we can say that this is a vector? Because whatever the solution that we got over here, it is in the form of unit vectors, combination of unit vectors called I, j and k. So hence we call it as vector. So curl of two vectors is a, or cross product of two vectors is a vector. Now I am giving 6 problems as exercises. So here for all these 6 problems, you have to find out the divergence of all these vectors. So when I say the divergence, we have to find out the dot product. That means del dot f we have to find out. Here also del dot f, here del dot g, here del dot f, here del dot g, here del dot g. That means whatever all the divergence values that you get, we know that divergence of any two vectors is a scalar. That means when you do the dot product between these two, del and the f, so that should be a vector. The final answer should be a scalar. That means no solution should have the values of I and j. Only it should have the magnitude but not direction. So first I'll say one example. So the vector field is xi plus yj. So f1 is x, f2 is y. Let us say we are finding out the divergence del dot f. So dou x by dou x plus dou y by dou y. So dou x by dou x is 1. Dou y by dou y is 1. So 1 plus 1 is equal to 2. If you observe this solution, so this value is a scalar because it doesn't contain any of the unit vectors such as I, j and k. So when there are no I, j, k's in our solution while performing dot product, that means it's a scalar quantity. Same in the case of the second problem. Here also after finding out the divergence of f, so we got only the value of x but not in terms of I, j and k unit vectors. Hence this is a scalar. So dot product of two vectors or divergence of any two vectors is a scalar. Same in the case here, if you see, special case is that here if you see we are getting del dot f as 0. That means we are getting a scalar value of which is equal to 0. When we are finding the divergence of any vector and if its value is 0, that means divergence of f or divergence of any vector f is vanishing, that means it is becoming 0, then that vector is called as solenoidal vector field. So when del dot f is equal to 0, that means divergence of any vector field f is 0, f is called solenoidal vector. When del cross f is 0, that means curl of f is equal to 0, that vector is called as irrotational vector. Now let us see again the fourth problem. G value is a vector with respect to its components x square I plus 2zj minus yk. Again using the divergence dot product, we have found out the value of divergence which is a scalar. There is no ijk, that means it's a scalar. Now if you see here, again we are finding out the del dot j value. After solving the equation, try to solve on your own. If you don't understand, go through the solutions which I have given over here. So after finding out the solution, compare with your solution. So if you see the solution over here, again there we are finding the divergence. Hence the divergence of vectors is a scalar. So if you observe here, no ijk components, that means which is a scalar. Again, I am moving on to the other question. It's in the exponential form or using logs. So don't get confused. So even though whatever form it may be, but when you do the dot product, so whatever the solution you got should be in the form of a scalar. Now we will move on to the finding out the curl of vector fields. So when we find out the curl of the vector fields, that means we have to take the determinant of the vectors. So which is nothing but del cross f, that means cross product. In cross product, the cross product of two vectors should be a vector. Hence, whatever the solution that we get at the end for each problem, that should be in the form of its components called I, j, k. Then only we say it is a vector. So if this is a special case, if you find when you are finding out the curl of this vector xi minus yj plus zk, so after taking the determinant, we have got our solution as 0. That means curl of f is vanishing. So when curl of f is vanishing, we call it as a irrotational vector field. So when curl of f is equal to 0 or else curl f is vanishing, then we call that vector f as irrotational vector field. The components of the vector, next question. If you move on, f is equal to, I have taken y cube I plus xyj minus zk and finding out the curl, taking the determinant. Finally, when we see the solution, at least one of its components should be there, unit vectors. That is either I, either j or k. So if you observe over here, we have got the solution in terms of k. K is a unit vector. That means or else k is the direction which represents direction. When any value is compounded by direction, then we call it as a vector. So this is magnitude and this is direction. So magnitude and direction combination gives us a vector. So that means curl of vector is a vector which is in the direction of k. One more problem, let us see. So here f is equal to, little complicated, but don't worry, you can able to solve, you are able to solve if you have followed whatever I have told in the earlier classes. So f is equal to xi plus yj plus zk by root over x square plus y square plus z square. Again we have to find out the determinant for this. So when we find out the determinant, so we got over here as the value as 0. Finally the solution is 0. And the I value we got as minus z by r cube. So in that way we have to solve our problem. Whereas if you observe here, again there is one more problem. So here we have taken f is equal to x square I plus 2zj plus minus yk, and we are finding out the curl. After finding out the curl using determinant, at last if you see the solution, it's in the component form called I. That means it's in the direction of I. So minus 3 is the magnitude, I is the direction. Magnitude and direction means it is a vector. Finally, I have given some problems for you to solve. Try to solve these questions and check the answers, whether you have done right or wrong, whether you are understood in a correct manner. First question, select the divergence of g x comma y comma z is equal to 2x cube I minus 3xyj plus 3x square zk. So here in the question we have to find out the divergence. Divergence means dot product. Dot product means del dot j. So del dot j, when you find out, so you will get the answer in one of the answer here. So next select the divergence of r by r cube, where r is equal to mod r and r is equal to xi plus yj plus zk. Again we have to find out the divergence of this value. So and find out choose the correct option which is given over here. Third question, we have to find out the curl of f, where f is x square I plus xyz j minus zk, and after finding the curl of f using the determinant del cross f, we have to substitute the value of 2, 1 and minus 2 in place of x, y and z. So after finding out the curl f, we have to substitute these values in places of x, y, z. You will get the answer. So you have to choose the correct option in these 4 options. Next. Now here he is asking to find out which is irrotational vector field in this 4 vectors. So how to find out the irrotational vector? I have just now told that. So irrotational vector is nothing but whenever we find out the curl of that vector, if that curl of that vector is 0, that means that vector is an irrotational vector field. So we have to find out the del cross F for this, del cross F for this, del cross F for this, and del cross F for the fourth option also. So when we find out the del cross F, if any of these four functions, four vectors, del cross F becomes 0, then that vector you choose as irrotational vector field. Thank you one and all for your patience listening. Signing off for today's session.